Assalamualaikum and hello everyone. So here we are again to discuss chapter 7 chemical bonding for the subtopic 7.3 intermolecular forces part 1. So for this part 1 actually we are going to learn about polarity and dipole moment of basic molecular shapes. Okay, our focus for this part is not the intermolecular forces itself, but the polarity and dipole moment in basic molecule. Before we go further, things you should know is Lewis structure, molecular geometry based on the Vesper theory, and electronegativity. Two terms that you will be frequently heard in this video is polar and non-polar. So for polar, we will have polar bond that will result in bond dipole and polar molecule determined by the dipole moment. We also have non-polar bond and non-polar molecules that will be determined by the dipole moment. So about this polar and non-polar bond and molecule, I will show you further in the next slide. Okay, what is polarity? So basically in chemistry, polarity is the separation or distribution of electric charge in a molecule or a bond. So bond polarity is due to the difference in electronegativity of the bonded atoms. The greater the difference in electronegativity, the more polar the bond. A covalent bond is polar if the two bonded atoms have different electronegativities. A covalent bond is non-polar if the two bonded atoms have similar electronegativities. So it is very useful for you to have together the periodic table in order for you to understand electronegativity and so that you will understand the polarity better. So as you can see from the periodic table, the arrangement of the atoms in the periodic table. So from left to the right, the electronegativity of the species of all of the atom are increased, and from the bottom to the top, the electronegativity of the atoms is also increased. So as you can see from the periodic table, the most electronegative atoms in the periodic table is fluorine atom with the Pauling scale of 4.0. So electronegativity is the ability of an atom in a molecule to attract the molecule's electron towards itself. Okay, so for bond polarity, we have two pictures here to represent polar bond and non-polar bond. So we have fluorine molecules and hydrogen fluoride molecules. So for fluorine molecules here, as you can see, the colorful cloud around the F and F atom here is represent the electron distribution. So fluorine and fluorine share their valence electrons to form bonding electrons. Okay, so electronegativity is same for both fluorine atoms. So the electron density is spread evenly around nucleus, and the highest electron density occurs between atoms. Bond is said to be non-polar. And for hydrogen fluoride atoms, molecules, okay, as you can see, the electron distribution is higher for fluorine and smaller for hydrogen because fluorine is more electronegative than hydrogen atom, so it pulls the bonding electrons toward itself. So fluorine atom acquires partial negative charge and the hydrogen atom acquires a partial positive charge. So we said that the molecule of HF is having a polar bond. For molecular polarity, the polarity is a quantitative measure of polarity of a bond in a molecule is its dipole moment. Dipole moment is defined as the product of the magnitude of the charge and the distance that separates the center of positive and negative charge. A dipole consists of partial positive and partial negative charge separated by a distance. So in the formula form, the dipole moment is called as mu is equal to magnitude of the charge delta and the distance d. Unit of mu is dBi, where 1 dBi is equal to 3.33 times 10 to the power of negative 30 centimeter. So dipole moment is a vector quantity, which means that it has magnitude and directions. Okay, the direction of polarity of a polar bond can be symbolized by a vector quantity, okay, shown by the arrow. Okay, so arrow points toward more electronegative atom is called bond dipole. So for the first example, we have hydrogen fluoride molecules. So you can see the picture here is the arrow is from hydrogen towards the fluorine atom. So the cross arrow from hydrogen less electronegative towards fluorine with more electronegative. And the second example is PCl5 phosphorus pentachloride. So we have 5 bonding pairs electron here. So we have 5 bond dipole. And all the bond dipole is pointed towards chlorine atom because chlorine is more electronegative than phosphorus atom. So molecule can be polar or nonpolar based on the dipole moment, based on the net dipole moment the molecule have. So if the molecule is polar, it is because the bond dipole do not cancel each other and give a resultant dipole moment where we say that the mu is not equal to 0. Mu here is dipole moment. Okay, remember earlier I told you that the dipole moment is symbolized by mu. A nonpolar molecule is when the symmetrical molecule bond dipoles cancel each other and the molecule did not possess a dipole moment where mu or dipole moment is equal to 0. Okay, so there is 3 steps to determine whether a molecule is polar or nonpolar. The first one is the electronegativity. So use the electronegativity values to predict the bond dipoles. Secondly, use the Vesper method, okay, to predict the molecular shape. And the third one is bond dipole. From the molecular shape, determine whether the bond dipoles cancel to give a nonpolar molecules or bond dipoles combine to produce a resultant dipole moment, hence give a polar molecule. Okay, now let's look for the polarity and dipole moment of basic molecular shape. So basically all the 5 molecular shapes has a 0 dipole moment and said to be nonpolar. Okay, so as you can see, for the first one is the linear. The 2 bond dipole pointing in opposite direction cancel out each other, so give a 0 dipole moment, and hence it is a nonpolar molecule. Okay, for trigonal planar, the same goes to trigonal planar of the bond dipoles. The 3 bond dipoles combine to form a 0 dipole moment. Okay, and tetrahedral, the 4 bond dipoles cancel each other, give a 0 dipole moment. And for trigonal bipyramidal, okay, the 3 bond dipole in a plane cancel each other and the 2 bond dipole vertically cancel each other. And lastly, for the octahedral, we have 6 bond dipole. So as you can see, the opposite bond dipole cancel, the another opposite bond dipole cancel, and the last opposite bond dipole cancel. So all these 5 give 0 net dipole moment. So all the 5 basic molecular shape is nonpolar molecule. To summarize the lesson today, so bonds can be polar or nonpolar depends on the atom it's bonded to. Molecules can be polar or nonpolar depend on the dipole moment. Diatomic molecules means molecule made of only 2 atoms. If atoms are the same, so molecule is nonpolar. If atoms are different, molecule is polar. So all molecules with basic molecular shape and have same terminal atoms are nonpolar. Okay, so before I left you with the video, so this is the some terms or keywords that you have to know: polarity, bond dipole, and dipole moment. So that's all. Hope you have understanding towards polarity and dipole moment, and have a nice day.